Hi, welcome back. In this video, we're going to talk about the triangle inequality. When this inequality theorem came out, man, people were mind blown. Okay, this is where the real followers started to happen. If we're talking back to like Pythagoras, talk back to Archimedes, back to some of these math legends that, well, at least I know. Anyway, let's talk about the triangle inequality and how big it is and the importance of it. And then if you find this useful, go ahead and hit the like button. And if you haven't subscribed already, you're missing out. So back in the day, people questioned this to themselves. They asked them, how can I make a triangle? And making a triangle is not very difficult. You just connect, three sides together, and you make three corners, and in the end you'll have three angles, which makes a triangle. But the question was not how to make a triangle, but how do you build one with dimensions, with its lengths, right? Can I just put any numbers and make a triangle? 3, 4, 5. Could I connect those and make a triangle? 10, 8, and 7. I mean, the question here was, can I just choose any three numbers and construct any triangle? So they used rope, they used string, they used things that had some certain lengths. Like, hey, what stuff can I put together to determine what makes a triangle and what doesn't? Am I limited to any lengths or not? So what we did in class is we used a straw activity to actually create it and figure it out. But I'm gonna break down the basics here. So they started with a longer piece, right? Let's say that this dimension is say 10 feet. And they questioned, like, well, can I just add another length over here? Let's make this 3 feet. Can I use the third side of this triangle as any other dimension, and would it still connect to this other corner? Right? Like, for example, if I use 4, the length of 4. Sorry, my bad. If we go with the length of 4, would that make a triangle? Would these pieces actually connect and construct a triangle? Now, this one would not work, right? But at what point would I be able to do it? Now, if I think about it, 3 plus 4 is 7. And if I try to connect these two, as I start to bring these two down to each other to connect them down in the middle, 3 would land somewhere over here. I'm going to change colors. 3 would land over here, and 4 would land over here, right? Because 3 plus 4 is 7. It's not big enough to make a 10. So it's not going to reach each other. It's going to be sort of like having dinosaur hands, right? Little T-Rex arms on the left. So then they're like, okay, well, there must be an amount that we need to at least make this work, right? How long do I stretch this for? I need to be able to construct it. If I do it something equal to 10, well, then it's just two flat lines, right? Like 5 and 5 is just equal to 10. Or 6 and 4 is equal to 10. I need to make it a little bit bigger so that I can then create some sort of an angle, right? So the bare minimum was like, well, these two legs that I'm looking for must add up to something greater than 10. So then you start looking at like 6 plus 5, right? That's long enough that would actually create this angle. So the rule here is this. The sum of any two sides of a triangle must be greater than the third side. In particular, we're worried about these two shorter legs, the small and the medium leg. If those two are long enough and it's bigger than the third side, we should be able to construct a triangle out of it. So we're going to categorize this as small, medium, large, I guess. We'll say this is the small side, this is the medium side, and this is the large side. Okay? So of any triangle, what we're going to be looking for is I'm going to put this together here. the small side, the medium side, and the large side. The sum of the small and the medium combined has to be greater than the third side in order for this triangle to work. It has to be. And that is actually the theorem. Okay? If you add up the two smaller sides, it must be greater than the third one, and it should be able to connect. Anything less than that, anything less than or equal to that large amount, would be too short, and they won't be able to reach each other. And in fact, as I showed you earlier, it'll just be flat, and it'll be two short little legs that won't even reach each other on the sides. All right, let's do some examples. So here we have a few examples. Is it possible to form a triangle with these possible lengths? Again, I'm interested in the two smaller sides. 9 plus 12. Combined is 21. 21 is definitely greater than 18. So yeah, this triangle would actually exist. If I look at the other one, 23 plus 26. Combined, we get 49. Unfortunately, 49 is not greater than 50. I should have written a 49 instead of 45. Right? 49 is not less. It's not greater than 50. So this would not work as a triangle. So as long as the two smaller ones add up to be greater than the other one, it should create a triangle. In this other scenario, we're only given two side measurements. Okay? So let's say that we have a triangle, and we know this is 6 feet, and this is 19 feet. What is the possibility for this third side that's missing in order for this triangle to work? Well, we know that 6 plus x has to be bigger than 19. So we start trying some numbers out. And the smallest number I can think of is 13.1. Right? 6 plus 13 is 19. We don't want it to equal 19. We want it to be a little bit more than 19 in order for it to work. So x has to be bigger than 13. So 13.1, 13.5, 14, it could be whole numbers or decimals, right? If I'm adding 6 plus 14, 15, 16, 17, it'll always be bigger than 19. Now, there is a problem here because I can't just choose any number bigger than 13 for this to work. Yes, adding them would be bigger than 19, but what happens at the point where this is no longer the larger side? What happens if I get to, like, say, 50? 6 plus 50 is greater than 19, but is 6 plus 19 greater than 50? And that's where the problem happens. 25 is not greater than 50, so this triangle would now become not a triangle. So here we are assuming the 19 is the larger side of these three sides, right? 14, 15, 16, 17, 18, 19. For all of those ranges, these two are small and medium where this is large. But then it comes to a point where 6 is a small, 19 is the medium size, and then this piece is the larger size. What happens is if that piece is the larger, then adding 6 and 19 is 25. 25 has to be greater than this piece, right? Combining these must, in order for it to be a triangle, this third side has to be less than 25 in order for this to actually work. So then I have to choose numbers that are less than 25, like 24, right? 6 plus 19 is 25. 25 is bigger than 24. That triangle works. If I try a number greater than 25, like 30, 6 plus 19 is 25. 25 is not greater than 30. That would not form a triangle. That would make these two legs, if this side was 30, it would make these two other legs really, really short, right? 16 and 19 would not even reach each other because 30 is too big. So x can be any value greater than 13 and at the same time less than 25. So x can be any number. The third side that's missing can be anything between 13 feet and 25 feet. how do we find this range of values, right? I mean, we can plug them all in, 14, 15, 16, 17, all the way to 24, and they would all work as part of the inequality theorem. A good rule of thumb is if you subtract these two numbers, you will get the lower boundary, the smallest that the triangle can be. And if you add them, you get the upper boundary, the largest the triangle can be. And then this third missing side could be anything between the lower boundary and the upper boundary. And that's how you find it. Subtract them for the lower boundary, add them for the upper boundary. All right, guys, let me know if you have any questions. I know that this topic was a little bit out there, but hopefully I was able to explain it in a way that it makes sense to you. If not, comment below and I can clarify some things for you. Go ahead and hit the like button, subscribe, and as always, we'll calculate later.